Hi everybody, the purpose of this video is to go over the homework associated with section 2.1 frequency distributions. So here we are. What we have here on my screen is the Hawkes Learning Systems display for this particular section. I have OneNote where I'll be doing some writing, and also for some of the problems it will be necessary to use a calculator to do some sorting. So we have that here as well. Okay, one of the things that you will notice about Hawkes Learning is that we have three sections. The first one is Learn, okay, which basically goes over the exact same material that I do in class. We have Practice, where you can actually practice what you've learned before you certify, and this is where you do your homework. Notice that if you actually, notice here that if you actually get 77% of all the problems correct, you will have certified, and if you certify before the due date, you will get 100. If you certify after the due date, i.e. if you do it late, you are going to take a penalty. I have not decided what that penalty might be. It will either be 30, 35, or a 40-point penalty. So it's important that you actually do your work and do it on time. Okay, so let's just go ahead and get into certify real quick. So notice here that we have 8 problems, eight questions, and some of these questions require multiple steps. As a matter of fact, there are basically a total of 13 steps that you have to do. And notice here is the number of lives. This is the maximum number of mistakes that you can make, or the maximum number of parts that you can get wrong. Once this goes down to 0, you did not certify, and you have to try again. So you're allowed for this particular homework to get 3 of the 13 questions, or 3 of the 13 parts wrong. So yeah, we have a total of 8 questions, but we also have a total of 13 parts. Okay, now to do the homework, I'm not going to go through certify. I'm going to do this through practice. So let me exit without saving, and let's go into practice. Okay, and here is the first of 8 problems. And here's what we have. We have a frequency distribution, and to read this, it says, consider the following frequency table representing the distribution of hours students study for an exam in a week. So here we are, and the question here is determine the class width of each class. Now remember, the class width is going to be equal to the difference between the lower limit of one class and the lower limit of the next adjacent class. Okay, and of course it's going to be a positive value. So notice here the lower limit of class 2 is 21. The lower limit of class 1 is 10. The difference happens to be 11. That is the class width. So you just want to come in here, click on the answer field, type in 11, hit enter. There you go. We did it right. And now we can move on to the next problem. So here we are, question 2, and this one also only has one problem. And notice here that we have a frequency table with the distribution of hourly wages for first jobs of a certain population, whatever it happens to be. It doesn't really matter. What we want to do is you want to determine the class width for each class. Once again, it is done the exact same way. It's going to be the difference of the lower limit between 2 adjacent classes. Class 2 here is 9.0 minus the lower limit for class 1, which is 7.8, and that should be equal to 1.2, if I did my math correctly. Actually, I hope I did. And there we go. I actually did something right. So now we're basically 1/4 of the way through. Well, not exactly, because we have 13 parts. So here's question 3. Notice this one has 2 classes. And we have here the frequency table representing the distribution of hours students study for an exam in a week. So basically that's the same type of table that we had, or distribution that we had for the first problem, although I think the numbers here happen to be different. Here we want to determine the lower class boundary for the first class. Now remember, the lower class boundary for the first class is going to be the average of the lower limit for the first class and the upper limit for the 0th class divided, which will be the sum divided by 2. The only problem is this is the lowest class, so we can't compute this right away. But what we can do is we can compute the upper class boundary for the first class. That will be equal to the lower limit or the upper limit of the first class plus the lower limit of the second class divided by 2. All right, well, the upper limit for the first class is 8. The lower limit for the second class is 9 divided by 2. That's going to give us 8.5. Do you really need to do this? Well, no, because notice here we have 8, we have 9, that will give us 8, and then the number in the middle, 8.5. But now that we know this, we know that the lower class boundary for the first class is going to be equal to the upper class boundary for the first class minus the class width. Now the class width is going to be equal to 7. The class width is going to be equal to the difference between the lower class limits of 2 adjacent classes. 9 minus 2, these are adjacent classes, that's equal to 7. Okay, cool. And that tells us that this is going to be equal, that the lower class boundary for the first class is going to be equal to 8.5 minus 7, which is equal to 1.5, which kind of makes sense. So this answer should be 1.5. So yes, finding the lower class boundary for the lowest class and the upper class boundary for the upper class is just a little bit trickier than the other problems. Okay, so we need to move on to step 2. Here is step 2. Here we need to find the upper class boundary for the second class. Okay, so here is the second class. The upper class boundary is going to be the number between this limit and then the lower of the upper limit for the second class and the lower limit for the next higher class or the third class. Notice here we have 15, here we have 16. That number should be 15.5. So you can kind of do it intuitively like that. If you want to be more precise, just remember that the upper class boundary for the second class is going to be equal to the upper limit for the second class plus the lower limit of the next higher class divided by 2. That is going to be 15 plus 16 divided by 2, 15.5. So hopefully that's right. Yay, I did something right again. Okay, and we're going to do this for a few more problems. So here we have, once again, a distribution of the cost of a paperback book in dollars. Okay, and now we want to determine the lower class boundary for the third class. Well, here's class 1, here's class 2, here's class 3. Notice that the lower limit for class, and so the lower class boundary for class 3 is going to be the number between the lower limit for the third class and the upper limit for the next lower class, 8.5. So the lower class boundary should be 8.55. That's the number between 8.5 and 8.6. Okay, once again, to be more explicit about this, the lower class boundary for class 2 is going to be equal to the lower limit, for class 3, of the third class plus the upper limit for the next lower class divided by 2. That will be 8.6 plus 8.5 divided by 2, 8.55. Okay, and then next we want to find the upper class boundary for the second class. Now, this one's kind of a gift because remember, the lower class boundary for the third class is equal to the upper class boundary of the next of the lower class, which happens to be the second class. So they both happen to be the same, 8.55. So that's almost kind of a gift. Okay, and we are little less than halfway through. Okay, Here, we want to consider the population, here we want to consider the following frequency table representing the distribution of hourly wages for first jobs of a certain population. And here, we want to determine the cumulative frequency of the fifth class. 1, 2, 3, 4, 5. Okay, now remember, the cumulative frequency is going to be the frequency of the fifth class plus the frequency of all the lower classes. So in this case, it's going to be the sum of everything. The frequency of the fifth class is 4, of the fourth class is 6, plus the frequency of the third class, which is 4, plus the frequency of the second class, which is 10, plus the frequency of the first class, which is 11, and that will give us 35. Okay, moving on, we probably have to compute the cumulative frequency for a second class, for another class, and yes, we do. We have here we have to determine the cumulative frequency for the second class. So the cumulative frequency for the second class is going to be equal to the frequency of that class plus the frequency of all the lower classes. In this case, there only happens to be one. That happens to be class 1. So that will be 10 plus 11, which is 21. And now we are more than halfway through. Okay, so here we want to consider the following frequency table representing the distribution of the cost to a pizza parlor for additional toppings on a pizza. Okay, so here they are. And we want to determine the midpoint for the second class. And remember, the midpoint is the number in the middle of the class limits. Okay, so here's the second class. The lower limit is 3.36. The upper limit is 0.45. The midpoint is going to be the number in the middle, or the average of the two. So the midpoint, I'll just call that M2, is going to be equal to 0.36 plus 0.45 divided by 2, and that will give us 0.405. Awesome. And next we have to compute another midpoint. This will be the midpoint for the fourth class. Now, if we know what this is, well, what we would need, and we know the class width is 0.1, so the second class was 0.405. This is going to be 0.505. This is going to be 0.605. So the midpoint for the third class is going to be equal to 0.405 plus the class width, which will be 0.36 minus 0.26, which is a 0.1, which will give us 0.505. The midpoint for the fourth class is going to be equal to 0.505, the midpoint for the third class, plus the class width, which should give us 0.605. Of course, this should be the same as 0.56 plus 0.65, the lower limit and upper limit for the fourth class, divided by 2, which of course is 0.605. So we actually get the exact same thing, which gives us a good degree of confidence that we are correct. There we go. And that moves us to the second to last problem. And here we have, at a state fair, one game involves guessing the number of candies in a plastic jar. The following data represents the guesses that people made during 1 hour at the state fair. Complete the frequency table for this data. Now, what you could do is essentially just using tick marks, try to figure out which data belongs, which value belongs to each class. Another thing that you could do is go ahead and sort the data, which would make it easier. Let's go ahead and sort the data. Now we can use our calculator to sort the data, and I'm hoping I can do this without messing it up too badly. Okay, so here's our calculator. Let me make this a little bit bigger so it's a little easier to see. And let's go ahead and put our numbers in. And of course, we need to be careful doing this. Okay, actually, let's start off where we would normally start off here. Remember, To enter in data, we want to go into stat, we want to go into edit, and when you can use any of the lists, we're going to use L1. And let's go ahead and put this data in. 1273, 1156, so I've entered all the data, and it might be a good idea just to make sure it's correct. So let's just walk through this just to make sure. We had 1333, 1222, 1114, 1284, 1176, 1132, 1117, 1117, 1246, 1062, 1081, 1108, 1214, 1142, 1156, 1273. Okay, now that we have this, we can go ahead and quit. Second mode will help us to quit. And now we can go ahead and sort. Now, what you can do is go into stat and sort the way we've done it before. Or since I actually have a sort ascending L1, we can just go ahead and click on that and bring that down and go and then hit enter and then enter again, and they will be sorted. Okay, of course. So that's one way to do it if you already have a sort in your history. If you don't, then you have to go the regular way, which would be stat 2, select a list. That will be second, stat, select L1, close the parenthesis, and then hit enter. The only point I want to make is that if you have this in the history, in your history, instead of going through all those keystrokes, you can just highlight the command and hit enter again, and it will do it for you. So basically, I've sorted this thing 1, 2, 3 times. Now that it's sorted, I can go back in, I can go and look at the data, and there we have it. Okay, and now that it's sorted, it might be easier to put in the frequency information. For example, the first class is between 1155 or between 1055 and 1104. That would include these two data sets are between that range, so this should be a 2. Okay. Next, we have between 1105 and 1154. That would include this one. So it's 1, 2, 3, 4, 5, 6 data items. Let's just make sure. 1, 2, 3, 4, 5, 6. Okay, now for the next class is between 1155 and 1204. So that basically includes this data value here, 1156, 1176, that will be 2. Okay, now I probably need to scroll down so we can see the rest of it. Okay, so we're sort of starting here, 1176. No, actually, we included that one. 1214. So between 1205 and 1254, we have 1, 2, 3. 1214, 1222, 1246. And then finally, well, not finally, now we want to look at the data values between 1255 and 1304. There happen to be 2, 1273 and 1284. 1, 2. 2, and then finally we have 1 in between 1305 and 1354. Now, to make sure that we are right, what we can do is sum up all of these values. These should sum to 16. So let's just go ahead and make sure. Here we have 2 plus 6 plus 2, that's 10, plus 3 is 13, plus 2 is 15, plus 1 is 16. So we have the right number. We have the right number of data values. If this was wrong, we know that we made a mistake somewhere. So let's just go ahead and see if we're right. And we are. And this brings us to our last problem. In this one, we have a frequency table representing the distribution of hours students spend on the internet in a week. Notice that happens to be higher than the students spend studying for a week. That's kind of disappointing. And to do this, and we want to find the relative frequency for the fourth class as a simplified fraction. So they want a fraction. Now remember, the relative frequency for the fourth class is going to be equal to the frequency of the fourth class divided by the total number of elements in the data set. Now the total number of elements in the data set is going to be equal to the sum of all the frequencies. And basically this symbol here is called sigma. It's the summation symbol, and all that is telling me is that I want to sum up F1, F2, all the way to F5, which will be 9 plus 13 plus 2 plus 6 plus 6, which will be 36. Okay, now if that's the case, then the relative frequency of the fourth class is going to be equal to the frequency of the fourth class, which happens to be 6, divided by 36. So that right here is the relative frequency. However, it has to be a reduced fraction, i.e., in other words, the numerator and the denominator cannot have common factors. One great way to check to determine the simplified fraction for a particular value is to use your calculator. So here's what we can do. Now a lot of you can look at this and know that, well, okay, well there's a common factor of 6, and this should be equal to 1, and the simplified fraction is going to be equal to 1/6. If you're not sure, this is something that you can do. You can compute 6 divided by 36. Gives you an answer. There it is. Click Math, okay, and then click Enter twice. Basically, this is going to give you the fractional form. Enter, Enter, and it will give you the simplified fraction. Notice here, this as a fraction is 1/6. That's the simplified fraction, so this is going to be equal to 1/6. And that's what we wanted to put into Hawks. Now to put this into Hawks, what you want to do is you want to click on the in the answer field, and then hit slash. That will give you your fraction, and then you can type 1. Use your cursor to go down 1. Type in 6. There you go. All right, now we can move on to our very last problem, and that is to compute the relative frequency for the second class as a simplified fraction. Well, the relative frequency for the second class is going to be equal to the frequency of the second class divided by n, which we know is 36. So this is going to be equal to 13 divided by 36. Okay, now once again, this has to be a simplified fraction. Fortunately, 13 is a prime number. The only factors for 13 are 1 and 13. Okay, as a consequence, this is already simplified. If you're not sure, you can go to your calculator, compute 13 divided by 36. All right, hit Math, hit Enter twice. There it is. That is your simplified fraction. So now all we need to do is click on our answer field, click slash, and then type in 13, go down with your cursor, 36, and submit answer. And there you go. There you go. And we are done. So that is pretty much how you do your homework. Although you can certify and get 100 with only getting 3 with omitting 3 questions, I would encourage you to go through all of the questions. It's not going to take you that much more time, and you never know if the question you skip might end up on a test. But nonetheless, that is how you do your very first homework assignment. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.